Hello students, in last video we came to know resonance energy. So already I told to come to know our next permanent effect, nothing but resonance effect. Okay, in permanent effect already we discussed about inductive effect. Now to discuss the resonance effect, already we told we have to come to know what is the resonance structures and what is the resonance energy. Okay, that already we came to know. Now let us discuss our second permanent effect, that is called resonance effect. Now what does the resonance effect mean here? The resonance effect is defined as the polarity produced in the molecule by the interaction of two bonds or between pi bonds and lone pair of electrons present on adjacent atom. So what does here means? Here simply before going to this one, clarity about this one, okay, I will go further. Here we have the two types of resonance effect. Okay, after that I will go further what is the meaning of this sentence. Okay, now here we have the two types of resonance effect. One is positive resonance effect, that is called plus R, and negative resonance effect, that is called minus R. Like already inductive effect also we came to know plus I minus I. Okay, like that here also we have the resonance effect plus R and minus I, minus R, sorry, minus R. Okay, resonance effect means we have the symbol R. So here we have plus R and minus R. So here if you see, here we have the resonance structures. Okay, so here if here resonance structures, while writing the resonance structure, see here we have the ring. Okay, so first you have to identify is it in the conjugation or not. Okay, you have to identify. So this is in the conjugation. So this is the structure of aniline. Okay, here we have the lone pair of electrons and nitrogen. So here first identify, do we have the conjugation? Yes, it is there. Why? Because means we have the alternate pi bonds are there. Okay, and here lone pairs and conjugation. Already we discussed what is the conjugation. Okay, just check it that video. So now here I am shifting the electron. See, this is the electron releasing group. Okay, here NH2 is the electron releasing group. Okay, now I am shifting the electron in such a way it is flowing the electron towards the ring. Okay, now this lone pair of electrons are coming here and here pi bonds are converted here, come to the atom. So in the first video we already came to know electron movements in organic molecule. Okay, now what happened, this lone pair is converted as a what bond, and here the pi bond converting as a what lone pair. Now here I am writing resonance structures. So resonance structure you can write as a what double head arrow, isn't it? Okay, now I am going to write the next structure. So if you write like this part is as such. Now what happened, now this is converted into double bond. Okay, now NH2 is there, so nitrogen going to get the positive charge. Okay, now so here what happened, here I am showing that lone pair of electron with a negative charge. Now this electron shifted to this carbon, I am showing the negative charge. Okay, next time what I am doing next, here the lone pair of electron shifted to adjacent bond, and again here pi bond is shifted to adjacent atom. Okay, and I am going to write the another structure now. So here what happened, if you write the structure now, so this lone pair of electrons converted into what bond. Okay, now this pi bond is shifted to adjacent atom, means writing as a what lone pair of electrons, simply I am writing as a negative. So remaining part as such I am not going to disturb here. So write that. Now I am here I'm going to write the another structure. Okay, so if you write the another structures, double head arrow you have to show. Now again, now I am shifting this lone pair of electron to adjacent bond, and this pi bond shifted to adjacent atom. So here what happened next, so this part is as such. Okay, I am not going to shift anything. Okay, NH2. Okay, now what happened here, now this is converted into as a what bond, and this is as a lone pair. Now if you write the again structure here, so here what happened, this lone pair is shifted to adjacent bond, and this pi bond electron shifted to adjacent atom. Now what you are going to get now here this one is the next structure. Okay, so simply now got your NH2, here positive charge will be disappear. Now here again if you shift, what happened, they are going to repeat. Now what I want to convince, now I shifted up to electron where I have to get the first structure. Now this structure and this structure both are same. Okay, now all these are called as a what resonance structures. Okay, now in the resonance structure what you are doing, the electron shifting towards the ring. Okay, you are going to shift the electron in the towards the ring, isn't it? So why? Because means we have the NH2 group, it is what? It has the electron donating capacity. So that's why it is calling as a what? Plus R effect. Okay. So now here if you see here, so the positive resonance effect means what? In this effect, the transfer of electron is away from an atom or substituent group attached to the conjugated system. So now what I did here, the electrons are moving away from atom. Here you can see it is moving from the what? This is the group or substituent. It is moving away from the atom. Okay. This electrons displacement makes certain positions in the molecule of high electron density. Now because of this, what happened in the ring, there is a electron density going to be increases. Okay, this effect can be shown as in the aniline. Okay, this is called as a what? This molecule is called as a what? Aniline. Already we came to know nomenclature. This is a what? Aniline common name. Okay. Now, so here what happened? You are talking about the what? Interaction here. Interaction between the pi bond and lone pair. While shifting of electron, what you are doing? Just you are going to shift the lone pair of electron and pi bond. Okay. Now in this example, we have seen the interaction between the pi bond and here this is the pi bond and this is the lone pair. Okay. Now this is example for the plus R effect. And if you other examples for the another group here for the here you have the NH2. Okay. Another example for this type of group means the atoms are group which show the plus R effect are halogen, OH, OR means if a group is present like this along with the NH2, if it is OH is there, or if you have the OR, or if you have under any other aniline like a primary, secondary, whatever the amines are, NH groups are there, all R can show the what? Plus R effect means the lone pair of electrons are shifting towards a ring. Okay, so this effect is called what? Positive resonance effect. Okay. To show the resonance effect, definitely you should have in the conjugation. The molecule should be in the conjugation. Next we have the what? Here negative resonance effect. Okay, that is called minus R effect. Negative means what here? Here again I am going for the example for the nitrobenzene. Okay. Okay, here we have the nitrobenzene example. Okay, this is structure of nitrobenzene. Now I am shifting only pi bonds in this both the cases. Now this pi bond is shifted to adjacent atom and this bond shifted to adjacent bond. Okay, resonance structures again you have to show with the one double head arrow on the both the sides. Now this structure is here up to here same as such. Now what happened? This bond is converted to double bond and now nitrogen going to get the what? Negative charge. Okay, now I name this oxygen as such. So once here it is losing the electron means here this carbon going to get the what? Positive. Now this carbon going to get the positive charge. Why? Because means already the pair of here pi bond electron is shifted to this carbon, isn't it? Now what happened now? I am shifting this pi bond to the adjacent bond. Now so already we told three types of moments are there. In that only I am going to shift according to those rule only. So here what happened? Now this is converted into bond. Now this carbon going to get the positive charge. Remaining as such we have the structure. Now N double bond. Here D2 bond O and O minus. Okay. Then now again I am shifting now. Again now what I am doing? I will shift this bond toward this side. So what happened now? Okay. So next structure here. Okay, you are going to get like this. Okay, here this is the structure. Now this carbon going to get the positive charge. So here this is a O minus and this is a one D2 bond O. Okay, now again after that here double bond is there now. Okay, I'm going to write double bond. Now again what again if you write the again if you go for the resonance structures, so this bond I will shift here. Okay, so what happened now? So if you write the structure now, so here we have the as such here. Now this bond converted into what? Here you are going to get the double bond. Now you are going to get the positive charge on the nitrogen. This we have the O minus. Then it's a D2 bond. So finally here if you write the structure, here again I am writing the other structure. So simply positive negative means they are going to combine and forming the what? Structure as the same as in previous one. Nothing but here going to get the double bond. Now this structure and this structure both are same. Okay. Now all these are indicating what? Resonance structures of nitrobenzene. Now if you see the here movement of electron. Now they are moving away from the ring. Okay, in the previous nitrobenzene what happened? They are moving towards the ring. Now they are moving away from the group, or this is grouping is taking the electron. In the previous what happened? NH2 giving the electron, but now this group NO2 group taking the electron. Let us see now. So here, if you see here what happened here, so this effect is observed when transfer of electron is towards the atom or substituent group attached to the conjugate system. So already we told. So if resonance you have to see means it should be in the conjugation. Now this is the system order in the conjugation. Why? Because means we have the alternate pi bond. Here you can see alternate pi bonds are there, isn't it? So for example, nitrobenzene, this here what happened? Here you can so here the shifting of electron you are taking like this, means this group is taking the electron, isn't it? So that's what it's calling as a what? Minus R effect or negative resonance effect. Now here you can see interaction on between two pi bonds. Now while shifting the electron, what I did? Only I did the interaction between the only pi bonds. I didn't touch any lone pair, isn't it? So here we this is the interaction between the only two pi bonds. The atoms are grouped which show minus R effect as COH, that is nothing but acid group, CH nothing but aldehyde, CN means cyano group. Now so along with this group, if you have in the benzene ring, okay, this is the benzene ring. If you have COH group R, if you have CHO group, nothing but aldehyde, if you have CN group, cyano group, all this present, the shifting of electron towards the group, nothing but you have to shift towards the group. That type of effect is called what? Resonance effect or minus R effect. Now let us see the what is the meaning of this sentence means. Here the effect is defined as here the polarity produced in the molecule by the interaction of two pi bonds are between a pi bond and lone pair of electrons present in an atom. Now here you can see here between the lone pair and pi bond, okay, because of interaction between the lone pair of and pi bond there is a polarity. You can see positive and negative charges are developed, isn't it? So because of interaction between the what? Lone pair and pi bond, polarity is developed. That is called what? Here resonance effect R. The interaction between the only two pi bonds. Two pi bond means what? Nothing but you can see minus R effect. Here you can see. Here this is example between the what? Between the two pi bonds. Now you are shifting with the only two pi bonds. So because of that reason what? Polarity, nothing but charges are developed, isn't it? Okay. This type of effect is called what? Resonance effect, and it will be permanent. Means in the molecule it will be exist. Okay. This is the what? Resonance effect. So resonance effect we have both plus R and minus R effect.